Okay, so exercise 8.2 first question. ABCD is a quadrilateral in which P, Q, R and S are the midpoints of the sides AB, BC, CD and DA. AC is a diagonal, so that SR parallel to AC, SR equal to half of the AC, PQ equal to SR, PQSR is a parallelogram. Okay, first you write the given. Okay, so the given. Okay, ABCD is a quadrilateral. In quadrilateral ABCD, like that you write. In quadrilateral ABCD. In quadrilateral ABCD, P, Q, R, and S are midpoints of the sides. Are midpoints of the sides AB, BC, CD, and DA. Okay. So now to prove, what we need to prove here? To prove so here as it is you write 1, 2 and 3 from the question. Okay, now I am going to prove SR parallel to AC and SR equal to half of the AC. So now you write the proof. Write on the proof. Listen here. You take to prove the SR parallel to AC, you have to select one triangle here.
Yes, sir.
The triangle
ADC.
ADC. Now you see, what is the midpoint of side AD?
S
is the midpoint of the side AD and R is the midpoint of side
DC.
DC. When you join these midpoints, so this is a SR line.
Yes, sir.
We need to prove here SR is parallel to AC and SR equal to half of the AC.
Yes.
Right. In triangle ADC, in triangle ADC, okay, ADC, S and R, write down. S and R are midpoints of the sides. Midpoints of the side. Midpoints of the side. AD and CD. Midpoints of the sides AD and CD. Okay, can I say now from midpoint theorem? SR is parallel to
SR is parallel to AC.
SR is parallel to AC and SR equal to
half
of the AC. So now you are saying this. This is from midpoint theorem. And within bracket you write here. This is from midpoint theorem. What is midpoint theorem? The line joining midpoints of the sides of a triangle is parallel to the third side and also it is half of it. Here the line joining SR is parallel to the third side means AC. SR is parallel to AC and also SR is half of the AC. Let us say this is equation 1.
Yes.
Let us say this is equation 1.
Equation 1.
Let us say this is equation 1. So we proved this and first one is over. Next second one.
First one.
So to prove second one, you select the another triangle. Everyone please look at it. So you see this diagram.
Triangle ABC, sir. Triangle ABC.
In triangle ABC. So everyone please see here. P is the midpoint of side AB and Q is the midpoint of side AC. The line joining the midpoints of the sides of triangle is parallel to the third side and also it is half of the third side. Okay, write down the same thing here also. In triangle, which one you have to take here? In triangle
ABC.
In triangle ABC. What are the midpoints of side AB and BC? P and Q. P and Q are midpoints of sides
AB and BC.
Very good. Midpoints of sides AB and BC. AB and BC. So from midpoint theorem, can I say now the line joining the midpoints of the two sides of the triangle is parallel to the third side and it is half of it. means the line joining the P and Q is a PQ, right? This PQ is parallel to the third side, means this is AC, and PQ is off of the AC. Write down that point. So PQ is parallel to AC and PQ is equal to half of the AC. So this is from 2. What is that? This is midpoint theorem. What is the midpoint theorem? The line joining the midpoints of the two sides of the triangle is parallel to the third side and it is half of it. Okay. So from 1 and 2 we can solve that PQ equal to SR. Right? So now you see here. Now you write down here from 1 and 2. From 1 and 2. So what is a 1? What is a 1? From 1 and 2.
Yes.
We need to prove PQ equal to SR. Everyone please look at it. PQ equal to SR. Now you see this half of the AC is equal to SR. Half of the AC equal to PQ. And these are both the things equal to the same thing. AC and AC. Okay. Things which are equal to the same thing are equal to each other. From these two, can I say now both are equal to half of the AC means that these two are equal to each other. Yes or no? Therefore, this is we can say that PQ is equal to SR. So why? Because the things which are equal to the same thing are equal to each other. Things which are you write here completely. Things which are equal to same thing are equal to each other. From 1 and 2 also we can know that here SR is parallel to AC and also PQ also parallel to AC. The line which are parallel to the same lines are parallel to each other. Okay, from these two, can I say now? Therefore, can I say now SR is parallel to PQ?
Yes, sir.
Why it is parallel? And this is from 1. Since it is from 1.
Things which are equal to same thing.
Okay, SR is parallel to AC and this is from 2. Okay, from these two, 1 and 2, can I say now SR is parallel to PQ?
Yes, sir.
The line which is parallel to the same line are parallel to each other. Now you see, in this diagram you see here, the line SR, this line SR is, the line SR is parallel to AC and this line AC also parallel to PQ. Then these two will become parallel to each other. Okay, and also we know that these two sides are equal. Okay, therefore can I say now? Therefore, from equation let us say this is 3. And from equation 3 also we know that what is that? PQ is equal to SR. Okay, PQ equal to SR and PQ parallel to SR. Therefore, can I say now PQSR is a parallelogram? Therefore, PQ, what is that? PQRS. PQRS. And this is the parallelogram. PQRS is, why it is parallelogram? You write in bracket, since a pair of opposite sides of a quadrilateral is equal and parallel. You write here, since a pair of opposite sides, a pair of opposite sides, a pair of opposite sides of quadrilateral, a pair of opposite sides of quadrilateral equal and parallel. A pair of opposite sides of quadrilateral equal and parallel. Okay, therefore PQRS is a parallelogram. Okay, is it clear everyone?
Yes.
ABCD is a rhombus and PQRS are the midpoints of the sides AB, BC, CD and DA respectively. Show that the quadrilateral PQRS is a rectangle. Okay, so we have drawn here rhombus, that is ABCD rhombus. Here we have the midpoints PQRS are the midpoints. When you join all these midpoints of the rhombus, so we have to prove that PQRS is rectangle. Okay, so first you write down the given. Everyone please write down. Given given. Okay, so ABCD is a rhombus, right? ABCD is a rhombus. Whatever there in the question, you write as it is. ABCD is a rhombus, and P, Q, R, and S are midpoints of AB, BC, CD, DA, respectively. As it is, you write here. So this is given. So what we need to prove? To prove PQRS is a rectangle. PQRS is a rectangle. So to prove PQRS is a rectangle, first we need to prove PQRS is a parallelogram, and one of the angle in the parallelogram, if it is 90 degrees, it is a rectangle. Okay, it will become rectangle. So one of the angle you prove that is 90 degrees. Okay. So construction. So just you join the diagonals AC and BD of the rhombus. Write on the construction. What we need to do here? Construction. So the dotted line you see there. Join the lines AC. Join diagonals AC and BD. Join diagonals AC and BD. AC and BD intersecting at O. Intersecting at O. So the midpoint you say here O. All of you write here O. Join diagonals AC and BD intersecting at O. Now first we need to prove PQRS is a parallelogram by using the midpoint theorem. Already we have done in the first question. The same thing you have to repeat here also. Okay. Then proof. All of you write down proof. Proof. To prove PQRS is a parallelogram, so what we need to do here to prove? So what is the first thing we have to do here? So we need to prove PQRS is a parallelogram. Okay. So for that I am taking here. Yes. What is that? For that I am taking here. Okay, everyone please look at here. To prove PQRS is a parallelogram, so what I am doing here, I am taking one triangle here. So what is the triangle you have to take here? Triangle ABC I am taking now. Triangle ABC. So all of you please observe the triangle ABC. In triangle ABC, okay, so now all of you please listen here. In triangle ABC, this is a triangle ABC, yes or no? This is a triangle ABC. In triangle ABC, what are the midpoints? P and Q are the midpoints, and which is parallel to the third side, and PQ is parallel to AC, and PQ is off of the AC. Okay, write down this. So this, all of you please observe this triangle ABC.
Yes, sir.
This is the triangle ABC. In triangle ABC, P and Q are the midpoint. The line joining the midpoint is parallel to the third side, and these two are the parallel lines, and PQ is equal to what?
Half of the AC.
Is it clear, everyone? So in which we are taking a triangle ABC. You see the triangle ABC. What are the midpoints of triangle ABC? P and Q. The line joining the midpoints of these P and Q is parallel to the third side AC, and also it is PQ is off of the AC according to midpoint theorem. Okay, write on that thing. In triangle ABC,
Yes. P and Q.
In triangle ABC, P and Q are
Midpoints.
midpoints of what?
Midpoints of
Midpoints of AB. So P is the midpoint of AB. By diagram we can say that. Okay. Q is the midpoint of BC. AB and BC. AB and BC respectively you write here. Respectively. P and Q are midpoints of sides. You write here sides. Sides AB and BC respectively. From midpoint theorem, can I say now? PQ is parallel to AC and PQ is half of the AC. Can I say like this? Yes or no?
Yes, sir.
Okay, let us say this is equation 1. Now you consider triangle ADC. ADC triangle low, sorry, in triangle ADC, what are the midpoints we have here? R and S. The line joining the midpoints of two sides of the triangle is parallel to the third side AC. Okay, and also it is half of the AC. Take the triangle ADC. In triangle ADC, okay, what are the midpoints you have to take as? Yes, R and S. Yes, R and S. R and S are midpoints of the sides. Midpoints of the sides. Midpoints of the sides CD and AD. Midpoints of the sides CD and AD respectively. From midpoint theorem, can I say now? RS is parallel to AC. RS is parallel to AC and RS is equal to half of the AC. Let us say this is equation 2. Okay, from 1 and 2. From 1 and 2. Can I say now? From 1 and 2. From 1 and 2. You see, both are parallel to AC. PQ also parallel to AC and RS also parallel to AC. The lines which are parallel to the same line are parallel to each other. From 1 and 2 we can say that PQ is parallel to RS, and now you see PQ is equal to half of the AC. Here also RS also equal to half of the AC. And can I say now PQ equal to RS? So you can write here the things which are equal to the same thing are equal to each other. So therefore we can say that PQRS is a parallelogram. Therefore we can say that PQRS is a parallelogram. PQRS is a parallelogram. Why it is parallelogram? Since a pair of opposite sides are parallel and equal. Since a pair of opposite sides are parallel and equal. You write there. Since a pair of opposite sides are parallel and equal. So you write here. The reason you have to write here.
Yes, sir.
Since a pair of opposite sides are parallel and equal. Okay, so now so we proved PQRS is a parallelogram. We need to prove angle P value equal to 90 degrees. Okay, so for that I am taking this. You observe this small box here, pink color box, right? So you observe this pink color box. P, what is that? You give one name here. Let us say this is X. Let us say this point Y. Already you know that in rhombus, diagonals bisect each other at 90 degrees. That means these two dotted line you observe here, these are the diagonals of the rhombus. They bisect each other at O, at 90 degrees. What is the angle O value here? 90 degrees. We need to prove angle P also 90 degrees. For that I am taking this one small box. First we have to prove this small box is a parallelogram. In parallelogram, opposite angles are equal. Therefore, angle P also equal to angle O. What is the angle O value? 90 degrees. Angle P value is 90 degrees. Now you see here. To prove that PXOY is a parallelogram, so what we need to do here? So all of you write here. Second one. So this is first one is over. So second one, PQR is a parallelogram. So to prove PXOY is a parallelogram, so what we need to do here? To prove PQR is a rectangle, here we have done one small construction. Let P, so write like this. Let PS bisects X at AC and PQ intersect BD at Y. Okay, so write down here. Let PS intersect AC at X. PS intersect AC at X. Okay, so we assume here this is a X. This PS intersect AC at X. Similarly, BD, sorry, what is that? What is that? PQ. PQ intersect BD at Y. PQ intersect BD at Y. PQ intersect BD at Y. Okay. So from this, you see here in quadrilateral PXOY. Everyone, please look at it. In quadrilateral PXOY, you take now. In quadrilateral PXOY. In quadrilateral PXOY. So we need to prove this PXOY is a parallelogram. Okay, so already you know that PS is parallel to BD. PS is parallel to BD. So can I write now PX is parallel to OY? How these two lines are parallel? So since here PS is parallel to BD. Okay, similarly here PY is parallel to OX. Since this PY is parallel to OX means the PY is also parallel to what? AC. PY is parallel to AC. So can I say now PXOY is a parallelogram? Therefore PXOY is a, why it is a parallelogram? Opposite angles of parallelogram are opposite sides of parallelogram. So opposite sides of quadrilateral PXO is parallel. Therefore PXOY is a parallelogram. In parallelogram, opposite angles are equal. Can I say now this angle P, this angle P is equal to angle O? Yes or no? Angle P is equal to angle O. How it is equal? These are the opposite angles of parallelogram are equal. Okay. Already you know that. What is the angle O value?
90 degrees.
How it is 90 degrees? You know that angle O equal to 90 degrees means in rhombus,
Diagonals intersect at 90 degrees.
Diagonals AC and BD. Diagonals AC and BD bisect each other perpendicularly. Bisect each other at 90 degrees. Completely I am not writing it. So bisect each other at 90 degrees, right? Bisect each other perpendicularly, you write like this. Therefore, if angle O value is 90, then angle P also 90. Why? Because angle P is equal to angle O. Okay, angle P is equal to 90. Therefore, can I say now PQRS is a rectangle? Therefore, PQRS is a rectangle. Okay, so in this way we can prove.